There are different ways of representing things. For example, a grocery list can be represented in this way, or in this way. In every way, it is the same grocery list with the same items. Nothing changed, just the way of representation changed. Likewise, a relation can be represented in 3 different ways, that are set builder method, roster method, and arrow method. Let's study the representation of relations in this session, but first understand what is a relation, domain, range, and codomain of the given relation. We know that for 2 non-empty sets A and B, the Cartesian product of A and B is the set of all ordered pairs of elements from A and B. That is, A cross B is equal to the set of all ordered pairs A, B, such that element A belongs to set A and element B belongs to set B. For example, if A is equal to set A, C and B is equal to set B, D, then A cross B is equal to ordered pair A, B, A, D, C, B, C, D. Now let's learn what is a relation. A relation R between 2 sets is a collection of ordered pairs containing one object from each set. If the object A is from the first set A and the object B is from the second set B, then the objects A and B are said to be related if the ordered pair AB is in relation R. Since we know that Cartesian product A cross B is the set of all ordered pairs A, B such that element A belongs to set A and element B belongs to set B, we can say that the relation R is a subset of A cross B. For example, consider the set A is equal to 1, 3, 5, 7, 10 and B is equal to 5, 10, 15, 20, 25, 30, 35 and 40. Now if we define a relation between the first and second elements, as the second element is 5 times the first element, how can you find the set R? The number 1 from the set A would be related to the number 5 through the relation R, or simply the ordered pair 1, 5 would be an element of R. Similarly, 3 would be related to 15, 5 to 25 and 7 to 35. So the relation R can be listed as the ordered pairs 1, 5, 3, 15, 5, 25 and 7, 35. The set of all first elements of the ordered pairs in a relation R from a set A to a set B is called the domain of the relation R. Now from the example, we consider the domain of the relation R equal to the ordered pair 1, 5, 3, 15, 5, 25 and 7, 35. Is domain D equal to set 1, 3, 5 and 7? Note that for relation from set A to set B, the domain would be a subset of set A. The set of all second elements in a relation R from a set A to a set B is called the range of the relation R. Hence, for the relation R, we considered the range of R is the set 5, 15, 25 and 35. The whole set B is called the codomain of the relation R. Note that range is a subset of codomain. A relation on a non-empty set A is said to be an empty or void relation if no element of set A is related to any element of set A. Consider set A as the set of all negative integers and the relation R on set A as the second element is the square of the first. Since the square of a real number cannot be negative, no element of set A is related to any element in set A. Thus, R is an empty relation. On the contrary, what is a universal relation? A relation on a non-empty set A is said to be a universal relation if each element of set A is related to every element of set A. Or precisely, the relation R is equal to the Cartesian product A cross A. Consider the set of integers I and a relation R that is defined as the modulus of the difference of the first and the second element is greater than or equal to 0. Since the modulus of any number is greater than 0 or equal to 0, the relationship is satisfied for any two integers. Therefore, R is equal to I cross I and it is a universal relation. Now you know that there are different types of relations. Is it possible to find the maximum number of relations that can be defined from a set A to another set B? The total number of relations that can be defined from a set A to a set B is the number of possible subsets of A cross B. It definitely depends on the number of elements in each of the sets A and B. If there are P elements in set A and Q elements in set B, then there would be P times Q elements in the set A cross B. You might have already learned that a set with n elements has 2 to the power n subsets. Thus, the set A cross B with the number of elements equal to P times Q can have 2 raised to PQ subsets. That is, the maximum number of relations from set A to set B is 2 raised to PQ. That were some basic definitions about relations. Now, how would you represent a relation? You might already be familiar with the ways in which sets and their Cartesian products are represented. The straightforward and easiest way to understand is the regular listing method within the curly brackets. If we got back to the previous example with the set A is equal to 1, 3, 5, 7 and 10 and set B is equal to 5, 10, 15, 20, 25, 30, 35 and 40, we have already listed the relation R, which is defined as the second element is 5 times the first element as the ordered pairs 1, 5, 3, 15, 5, 25, 7, 35. This method of representing a relation is known as the roster method. Another form in which relations are represented is the set builder method. As in the case of sets, this form makes use of the relationship that the first and the second element in the ordered pairs possess. Let us go back to the example. In the set builder form, this relation can be written as the set of all ordered pairs x, y in A cross B such that y is equal to 5x. Another way to represent a relation is using an arrow diagram. This can be done by representing the elements of the sets A and B in separate closed curves, usually circles or ovals, and connecting the related elements using arrows. Consider the given example. The relation R can be represented by first taking the elements of A and B in ovals and then connecting 1 to 5, 3 to 15, 5 to 25 and 7 to 35. To summarize, A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. It is derived by describing a relationship between the first element and the second element of the ordered pairs in A cross B. The set of all first elements of the ordered pairs in a relation R from a set A to a set B is called the domain of the relation R. And the set of all second elements in a relation R from a set A to a set B is called the range of the relation R. A relation on a non-empty set A is said to be an empty or void relation if no element of set A is related to any element of set A. Whereas, a relation on a non-empty set A is said to be a universal relation if each element of set A is related to every element of set A. The maximum number of relations from a set A with P elements to a set B with Q elements is 2 raised to PQ. Algebraically, a relation can be represented either by the roster method or the set builder method. An arrow diagram is a visual representation of a relation. Now that you've learnt about all the 3 representations of a relation, do it yourself. Take the relation in one form and write them in the other 2 forms. We will learn more about relations and functions in our upcoming sessions.
Keep imbibing. We believe in you.